Okay, so in the last lesson we learned transformations, and the reason we use transformations is because we want to be able to sketch the graph in order to answer some key questions about the key attributes. And so if we need to find the vertex, axis of symmetry, domain, range, it's so much easier if you have a picture to look at. And so looking at this function, it's the absolute value function that has been vertically stretched by 2, left 5, and down 4. And so if I were to sketch this graph or picture it, I would move to the left 5 and down 4. And so that would put the vertex right here at -5, -4. And then this vertical stretch by 2 just changes the slope of each branch from up 1 over 1 to up 2 over 1. So it would go up 2 over 1, and then in the other direction as well. And then to answer these questions, we don't need a perfect graph. We just need an idea of what it's looking like. And so that's good enough for what we need. And so now we can identify everything. The vertex is this point right here at -5, -4. That's the vertex. The axis of symmetry, remember, is that vertical line that goes right through the vertex. And so it's always going to have an x equals equation, and it's always going to match the x-coordinate of the vertex. Don't forget the x equals, otherwise you did not write the equation of a line. You just wrote a number, and the axis of symmetry is a line. Okay, and then for domain, that one's always all real numbers. And then for the range, we have the minimum value right here at -4. And so the range runs from, let me write that in purple, -4 with the bracket to infinity. Okay, and so if we ever need to find the vertex, axis of symmetry, domain, and range, we can use transformations for that. We can look at this function's equation and know how to answer all of these questions. Even if we don't have a picture, we can draw it out or picture it in our mind. And so there are other key attributes that aren't as easy to use the transformations for, but for the vertex, axis of symmetry, and domain and range, you want to use transformations. Meaning you want to picture the graph. And so over here to the right, we have the graph. And so we know the vertex is 2, -2. We know the axis of symmetry is x equals 2. Domain is all real numbers all the time. And then the range, we have a minimum here at -2 and it goes up to infinity. So the range goes from -2 to infinity. Now the x-intercept and y-intercept, remember the x-intercept is where it crosses the x-axis. And so there's 2 of them, just like with a parabola or a quadratic function. So we have 1, 0, and we have 3, 0 for the x-intercepts. For the y-intercept, it's where it crosses the y-axis, and so 0, 2. Remember, the y-intercept is a y value for when x is 0. So y value when x is 0. The x-intercept is opposite. It's an x value for when y is 0. And so we're going to use that fact to find them algebraically in the next examples. And now for max and minimum, they're going to give you a interval of numbers that you're allowed to look at. And so here they didn't cut off the domain. The domain is all real numbers. And so there is a minimum, but not a maximum. The maximum does not exist on this interval of all real numbers, but the minimum value is -2. In some later examples, we're going to say, okay, what's the minimum and maximum if I restrict the domain from -1 to 3? And in that case, we would just have this window of numbers to look at. And so we would have a maximum, and we would still have a minimum. And so D&E will not be an option for those kinds of questions. Okay, so for example 1, we already talked about how to find the domain, range, vertex, and axis of symmetry. So for part A, we're going to talk about how to find the intercepts. And so for the x-intercept, you're plugging in 0 for y. You're looking for the x value when y is 0. Okay, so you're going to take this equation and plug in 0 for the output. And so we just have to solve the equation 0 equals 2x plus 5 minus 4. Okay, and so the first thing you want to do when you're solving this equation is isolate the absolute value bars. And so to isolate the absolute value, we have to get rid of this 2, and we have to get rid of this -4. Okay, the -4 has to go first because it's not attached, just like when we're isolating a variable. So the first thing I'm going to do is add 4. And then divide by 2. Leave the bars alone. And so once you've isolated what's inside the bars, you're going to set what's inside the bars equal to the +2 and the -2. And so we have 2 equations to solve. In one case, we get -3. In the other case, we get -7. And so the x-intercepts are -3, 0, and -7, 0. The y-intercepts are a lot easier. The y-intercept is you're looking for a y value when x is 0. So here we replace the x with 0. Okay, and so I'm solving the equation. Oops. Or evaluating the expression, really. And so y equals 2 times the absolute value of 5. And then the absolute value of 5 is just 5. So 2 times 5 is 10. And so y equals 6. So the y-intercept would be 0, 6. Okay, so label what you have here. The x-intercepts are blue, and the y-intercept is green. Okay, and so for the maximum and minimum, it's nice to have a picture of what this graph is looking like. And so we sketched it on the warm-up. It's left 5, down 4, and it's opening up. And so if I restrict the interval from -9 to 1, -9 is over here, and 1 is over here. Okay, and so we're looking for maximum and minimum of this blue function, but we're limiting the domain to just between these two values. Okay, and so having this picture helps us a lot because we know the minimum. It's going to be where the vertex is. Okay, and so the minimum value is -4. That is what's called a global minimum. No matter what we restrict the interval to, as long as this vertex is on that interval, that's going to be the minimum. The maximum for this function is going to occur at one of these endpoints. It's either going to be here or here, since the function is increasing as we go this way and increasing as we go this way. And spoiler alert, it's always going to be at the endpoint that is further away from the vertex. So obviously it's going to be this point right here. But if you want, check both. And so you can plug in the -9 and you can plug in the 1, each of those for your x value, and see which one gives you a higher value. And so if I plug in -9 for x, I'm going to get -4 inside the bars, because -9 plus 5 is -4. And then the absolute value of -4 is +4, giving me 8 minus 4, which is 4. That's if I plug in -9. If I plug in 1 to the function, I'm running out of room. We're going to plug in 1 to the function, so let's do that right here. Replacing x with 1. We get 8. And since 8 is higher than 4, 8 is going to be the maximum. Okay, and so over here, the minimum is -4, and the maximum on that interval is 8. So we can't say does not exist anymore because we are restricting the domain to this interval, -9 to 1. And so 1 at x equals 1 is where the maximum occurred, and the maximum was 8. Minimum and maximums always refer to y values. Okay, so example 2. The vertex, axis, symmetry, domain, and range, those are always going to be the easiest key attributes because we can just use our transformations. And so this function has been reflected across the x-axis, so I know it's upside down, and then it's also been moved right too. And so if I get a nice pretty sketch over here, the vertex is at 2, 0, because it didn't move up or down, but now our function is opening down. Okay, and so I can answer all of the questions. The vertex is 2, 0, axis of symmetry, x equals 2, domain, all real numbers, range goes from -infinity to 0 bracket because it's opening down. Okay, all that's a review from using transformations. So vertex, axis of symmetry, domain and range. Easy key attributes. Intercepts are a little bit harder. But this one's actually easier because if we sketch our picture, there's only one x-intercept because the vertex is right there on the x-axis. If it were shifted up a little, we would have two x-intercepts. But if it doesn't move up or down, your vertex is your x-intercept. And so for the x-intercept, there's just one this time, and it's 2, 0. For the y-intercept, remember it's a y value because it's a y-intercept when x is 0. And so we take this expression, plug in 0 for this x. Okay, we have a negative. 0 minus 2 is negative 2, but absolute value of negative 2 is positive 2. But we still have this negative, and so the y-intercept is 0, negative 2, which makes sense according to our graph. Okay, now for the maximum and minimum on this interval. So I'm going to sketch the picture again. And this time they are restricting the interval from negative 2 to 3. Okay, so 3 and then negative 2. That's where we're cutting the function off. And so the function's going to keep going and meet here and here. And so if we're talking about the maximum, well, our vertex is right in the middle of this interval. And so the maximum is the vertex value this time. And the maximum is 0. It's right here on the y equals 0 line. The minimum is going to be the one that occurs at one of these endpoints. Okay, and here it's obviously at the negative 2 because it's further from the vertex. But again, you can check them both if you want. So if I plug in negative 2, negative 2 minus 2 is negative 4. Absolute value of negative 4 is positive 4, but we still have that negative outside. And so we end up getting y equals negative 4 over here. Okay, if you want to double check, like you would on a test maybe, we can plug in 3. And so that would be this point here. And so if I plug in x equals 3, I end up getting negative 1, which is not lower than this negative 4. And so the minimum is negative 4. Maximum is this point. Minimum is this point. Okay, this is the last example. And so remember when you're using transformations, don't say this has been moved right 8. You have to divide by whatever's directly on the x in order to figure out left and right. And so this function, because of this 2, it has been horizontally compressed by 1/2. And then instead of right 8, it's actually only been moved right 4 because we have to divide by this 2. So horizontally compressed by 1/2, and then right 4, and up 9. Okay, so sketching my picture, right 4, up 9, it's way up here. And then it's been horizontally compressed, so it's going to be narrower. And so looking something like that. Okay, and so again, here the intercepts are going to be a little bit easier because looking at this picture, oh, we didn't answer any of those questions. The vertex is for 9. The axis of symmetry, x equals 4. Domain, all real numbers. Range goes from 9 to infinity. Now for the intercepts, there are no x-intercepts here. It never crosses the x-axis. And so having that picture saves us a lot of heartache. We just say does not exist. That can happen. And if you tried to plug in 0 and solve for them, the first thing you would do is subtract 9. And then you would see right here that you have absolute value equal to a negative number. And distance, which is absolute value, can never be negative. And so this right here tells you it does not exist. Okay, for the y-intercept, we do have a y-intercept. This function will eventually reach the y-axis. We just have to plug in 0 for our x. And so for our y-intercept, we end up with 0 minus 8 inside the bars. An absolute value of negative 8 is 8, which gives us 17, which makes sense if we look at our picture. And so our y-intercept, 0, 17. This picture is very, very helpful. All right, now to find the maximum and minimum. So let's get a picture again. I'm going to make this, we'll put the y-intercept here at 17, then the vertex here. Not drawn to scale, but we've got a good idea. All right, so we are chopping off the interval from 2 to 10. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and so we're chopping off from 10 and then 2. Okay, so here, this function is going to keep going and eventually have an x equals 10 value. And so for our minimum, there's our vertex right in the middle of the interval. And so the minimum is at 9. The maximum is probably going to occur here, but you can plug in 2 as well. You're not going to get a higher value though. And so for the sake of time, I'm just going to plug in the 10. So absolute value of 12 is 12, plus 9, I believe, is 21. And there's another example. Let's see what this one does. All right, this function has been vertically compressed. It hasn't been moved left or right, but down 3. Okay, so it's actually wider because the slope is now 1/2, but we've got enough information to answer these questions. Vertex 0, -3. Axis of symmetry, x equals 0. Domain are real numbers. Range goes from that -3 to positive infinity. Okay, for our intercepts, let's get our picture. I'm tired of red. Okay, so this is an example that has 2 x-intercepts, and then we can already see the y-intercept because it's the vertex. And so I'm going to answer the y-intercept right now. It's 0, -3, right here. Okay, for the x-intercepts, this time we have 2. And unless you have a good enough graph, you're going to have to solve for them again. And so since I don't have a good graph, I'm going to plug in 0 for y and solve for the 2 answers. Okay, and so first things first is you have to isolate the absolute value. So this 1/2 has to go, this -3 has to go, and the -3 has to go first, whatever's not attached to the bars. So you add 3. And then to get rid of this 1/2, you would just multiply both sides by 2. Multiply by the reciprocal. Okay, and so those cancel, giving us 6 equals the absolute value of x. Now we set what's inside the bars, which is just x, equal to the +6 and the -6. And those are our answers. And so for our x-intercept, and they should be symmetrical anytime the vertex is right there in the middle on the y-axis. So our x-intercepts are -6 and +6. And so for x-intercepts, you notice you can have 2, you could have 1, or you could have none. So in this example, we had none. In this example, we had 1. For y-intercepts, you're always going to just have 1. All right. I think, yep, this is the last part. So max and min. Okay, so let's get our picture. We know that the x-intercepts are at -6 and 6. And the y-intercept is at -3. Not drawn to scale, but good enough. So now we're looking from -10 to 1. So -10 to 1. That would be -10 to 1. And so once again, our vertex falls in this interval. And so we've got our minimum. And then for our maximum, it is not going to be at 1. It is going to be at this -10 way over here. No, so now we just need to plug in the -10. Absolute value of -10 is +10. 1/2 times 10 is 5. So 2. Okay, and so you are going to have a practice worksheet on that. I'm probably going to record a video to make the answer key. And so try the practice worksheet, and then you can check with the video or the answer key.